Welcome to our lesson video for day 2 of Unit 2 in Geometry. We're going to continue on with some of the same things we were talking about in the previous lesson about how to write two-column proofs. And we're going to be proving statements about segments and angles this time instead of just proving statements about equations. Like we did last time, we did some algebra review where we solved equations and we set those up as two-column proofs. Okay, in a two-column proof, remember there's a statement and reason column. All of the statements are the steps of working out your proof, going from your given down to what you're trying to prove. Okay, so that's a quick review of what we did last time. And we're going to pick up right here in the notes. But the first thing I want you to do is just take a look at this next portion because it's kind of important to review a couple things that we've been talking about over the last few weeks. We have certain segment relationships and angle relationships that are going to show up in today's lesson. One of those is called the segment addition postulate. Okay? The segment addition postulate, that's how you abbreviate segment addition postulate, is basically anytime we have a part plus part equals whole. So if I have some kind of situation like this, where I have a segment A, B, and C, or points on the segment A, B, and C, creating segments AB, BC, and AC, then I know that these individual parts add up to the same as the whole thing. Okay? But if I tell you that B is actually a midpoint, if I tell you it's a midpoint here, if B is the midpoint of AC, then that makes these congruent segments. Okay, that means part equals part. So in this case, that would mean AB would equal BC, or I could do 2 times either of those parts. So let's say we did 2 times the length of AB. That would also have to equal the length of AC. Okay, and so we have those segment relationships, and we're going to use some of those today. But we also have angle relationships that kind of work out the same way. So if I've got an angle situation where 2 angles are adjacent and they form a bigger angle altogether, again, part plus part would equal whole. So if I label these points here, then I know angle ABC plus angle CBD have to equal the same as the total angle ABD. Okay, part plus part equals whole. But if I tell you that we have an angle bisector, hold on just a second, let me clear that out. If I have an angle bisector here, that means these are congruent angles to each other. They're equal. That means one part would equal the other part. So I could say angle, or the measure of angle ABC would have to equal the measure of angle CBD. Or 2 times one of the individual angles equals the whole thing as well. But we're going to use this part equals part equation a lot today, for both segments and angles. So let's take a look at the notes. In the first example, we are given this picture. This is really important that we identify and use this picture. Okay, that fits this expression. We're told T is the midpoint of SU. That means these are congruent segments to each other. ST and TU are equal to each other in length then, which is part of my proof that you'll see there. But this is also part of the given. Any picture you're given is considered part of the given information. So technically, we do need to add something here. We need to add to our given that ST equals the expression 7x and TU equals the expression 3x plus 20. I need to have that as part of my givens. So I want to copy all that given information down. I want to say T is the midpoint. You can abbreviate MDPT period. That's midpoint. T is the midpoint of SU, and ST equals 7x, and TU equals 3x plus 20. Okay, just copying down all the given information, either from the line given or from our picture. Okay, and that reason is just that it's given to me. If you'll remember last time, that first line is always the given statement, and the first reason is always the word given. Okay? Now the next line is given to us, filled in already, and it just says ST equals TU. Well, that's what this word midpoint means. That's what midpoint means for us. If we go back here to our pictures here, these are some definitions I gave you. Anytime I'm saying that one part equals the other part, that's what midpoint means. And so in our reason for our proof, if we're using the meaning of the word midpoint, we can always call it the definition. Let me use the right tool. Here you go. The definition of that word midpoint. Now, I will also accept the phrase part equals part. Whichever way is easier for you to remember, it's okay to use either one of those. That's why I know one part equals the other, because of the word midpoint. All right, and then the next line here is substitution. Well, what can I substitute? I know the expression for 7x and 3x plus 20. Those are equal to these parts. And so instead of my ST, I'm going to write 7x because that's what it equals. And instead of TU, I'm going to write 3x plus 20. All I'm doing in these proofs, instead of just starting with some random equation, I'm giving you a geometric relationship to start with and using some algebra expressions to solve for these situations. So all I've done here so far is substituted in for these values right here, because I know what each one is equal to from that. And so now it's just a matter of solving the equation like we did in the previous lesson. The first thing we want to do is subtract the 3x from both sides. If we subtract 3x from both sides, we get 4x on the left and 20 on the right. And since we subtracted 3x from both sides, that would be the subtraction, POE, property of equality, remember from last lesson. And then we need to divide both sides by 4 to solve. So we write x equals what the result is of doing 20 divided by 4. 20 divided by 4 is 5. And that's what we were trying to prove here. And the reason we can write that last statement is that we divided both sides by that. So it's the division property of equality. Now, if you need to make little notes to yourself out beside here, okay, we subtracted our 3x from both sides. So 7x minus 3x gives us 4x. And we took our 20 and divided by 4, and we got our 5. So it's okay to make some little notes along the side as you go. All right, let's go ahead and go to our next proof. Kind of the same idea. The picture looks a little different, but we do have all the same information that we are given. We're told B is the midpoint. Okay, our given here is that B is the midpoint of segment AC, and we know AB is 6x and BC is 2x plus 12. So again, we want to start with all the given information. And I'm writing pretty small to try and fit it all in. B is the midpoint of AC. We know AB equals 6x and BC equals 2x plus 12. That's all my givens. Okay? And then this time I filled in the reason for you. Again, I gave you that definition of midpoint, or you might also see it as part equals part. That's what midpoint means. This midpoint means that this segment, AB, has to be the same length as the other part segment, BC. If it's the midpoint, these are equal parts on both sides of that point. Now, we can kind of ignore that line going down through it, that ray, dB. It's not necessary for our picture, but that's the important relationship, that 6x and 2x plus 12 really have to be the same as each other. So since we're using definition of midpoint, the first thing we're going to fill in is that these lengths, AB, that's one part, is equal to the other length, BC, the other part. We always want to do this general form first before I substitute in. If we were just solving this, if this was just a problem where I said find the value of x, you wouldn't necessarily start with that one. You would just plug right into it. But because we're doing a proof, we need to give a reason for why we write each statement. So the first thing we have to do is write AB equals BC. Then we can substitute in 6x for AB and 2x plus 12 for BC. And now I have an equation that I can solve like last time. I want you to pause the video here so that you can try and finish this problem on your own. When you are ready to continue, click play and you can see what the answer should be. All right, if you need more time, keep the video paused here, but otherwise these are the next steps that we should have. The next thing I'm going to do is subtract the 2x from both sides, giving me 4x equals 12. The reasons should be subtraction, property of equality. And finally, divide by 4 on both sides, and x does equal 3 because of the division property of equality. Okay, so these proofs are very similar to what we did in the last unit, or last lessons, but we are starting with the geometric relationship instead of just starting with the equation. Now, these next two are not proofs, okay? We're not doing a proof. We are just using those geometric relationships to solve problems. Okay? We do not have to prove anything. You don't see the word given. You don't see the word prove. So there's no proof that we have to write here. All I want us to do is solve for the value of x and find a length of BC given this relationship. Okay? We are starting with this relationship. Otherwise, there's no way to know anything about x or these lengths. But these relationships are really important. We are told AB equals BC. So I'm going to mark those as congruent with the little tick marks. Anytime we have congruent lengths, we can mark them congruent with these tick marks. But we're also told that BC is equal to CD. That means this same tick mark at BC is also equal to CD. So all three of those segments are equal in length. Even though they don't all line up together, they're equal in length. Since AB is equal to BC and BC is also equal to CD, I can say that AB has to equal CD because of the transitive property. We talked about that in the last lesson. We can transfer the equality from here to the equality here and say that AB has to equal CD. That's called the transitive property. Now I can go ahead and just fill in what I have. I know that AB is x plus 3. I know that CD is 12 minus 2x, and all I have to do is solve that for x now. What I would do for solving for x is take this and add 2x to both sides. Since this is not a proof, I'm going to go ahead and just show those steps. That leaves 3x plus 3 equals 12. Then I would do minus 3. Sorry, 12 minus 3 is 9. And then think about what our last step should be. Our last step, we need to get rid of that 3 in front of the x, so we're going to divide by 3. So we get a final answer that x equals 3. Now, that is one part of my final answer. It says solve for x. But you were actually asked to also find the length of BC. Now, BC does not have an expression listed out here. Okay, BC is that middle expression there. But remember, all three of these are equal. AB equals BC. So I can plug into either one of these. I'm going to plug into this one because it's easiest. So BC is actually the same length as AB, which is x plus 3. So I can substitute my value 3 for x into that place where the x is, and end up doing 3 plus 3, which is 6. So the length of BC is 6. And there's the two answers we need to have. All right. One more example, and this time we're using angles, and it can be a little tricky to understand what these angles are. So I'm going to use some highlighting and kind of show you which ones are which. But they want you to solve for x, and that's actually a typo, because if you look at these expressions, there's no x's given. If you look at the expressions, we are solving for h, so please cross off the x and write h. So we will have an answer h equals, and then they also want the measure of angle in KL. The measure of angle in KL, and I will outline that for you here. In KL is this angle. I want that angle measure. Well, they find an expression for NKL here, And we're told that NKL is equal to MKN. But MKN, I'm kind of working backwards, is also equal to JKM. Well, these are those three angles. JKM is on this side, and MKN is in the middle. But all three of those pieces are actually equal to each other because of the transitive property. JKM can transfer its equality through the common angle MKN to the final angle NKL. So I can say the measure of angle JKM has to equal the measure of angle NKL. Again, if I was giving a reason in a proof, that would be the transitive property. But this is not a proof. I don't have to give a reason for everything, but I do want you to realize when we're using those specific reasons. So since JKM and NKL are equal, I can replace their values with these expressions. So JKM is 2h plus 7, and NKL is 4h minus 13. And all we have to do is solve for h now. What I would do is subtract 2h from both sides first. That way we don't have an h or a variable on different sides of the equal sign. That leaves us with 7 equals 2h minus 13, because 4 minus 2 is 2. Then I would add the 13 to both sides, giving me 20 equals 2h. And then finally divide by 2. And flip it around if you want, h would equal 10. So there's part of my answer, h equals 10. But I also want the measure of NKL. Well, that means I'm going to take this expression here, and I'm going to plug in 10 for h. So the measure of angle NKL is equal to 4. Instead of times h, I'm going to do times 10, because I know h is 10, and then subtract 13. 4 times 10 is 40. And then I need to subtract 13 from 40. 40 minus 13 is 27. So the measure of angle NKL is 27 degrees. So those are the kinds of proofs we're going to do and the kind of angle relationship problems or segment relationship problems that we're going to use in today's lesson.